this particular session, actually this is the first session regarding network theory subject, regarding SSC JEE previous year questions. Okay, so in this particular subject, network theory subject is a basic subject and scoring subject for SSC JEE technical part. Okay, so with respect to paper 1, okay, so currently I am going to discuss the questions from the first chapter. Similarly, in the upcoming sessions, I will be discussing the questions based on the upcoming concepts and upcoming chapters as well, right? So in this particular session, I am going to discuss the questions which covers the concepts like active elements or sources with respect to current or charge, power, energy, and then passive elements like resistor, inductor. Okay, in the next session we will be discussing the questions based on capacitor and then basic laws, etc. Okay, so whatever the previous year questions, recent year questions which are asked in the SSC JEE exam, I have kept in this order, in this sequence, and even in the upcoming sessions also I am keeping in the order, so that whoever attending these sessions, they are getting two-way benefit. Okay, whoever thoroughly prepared by this time, definitely while you are solving these questions, okay, if you are getting correct answer, that means your confidence level is increasing. Okay, but somehow other, if you got wrong answer, no issue, you can just focus on my explanation or whatever I am solving for that question. Then with the help of that, you can correct it wherever you are doing the mistakes. And one more important update, because if you are solving the questions in this particular order, you are getting the revision also. Okay, so in this way there are lot of benefits are there. Okay, whoever attending this particular series of lectures regarding network theory subject. Okay, so all of you kindly like and share this video link with all of your friends, especially this series of videos are going to helpful whoever write in the SSC JEE exam paper 1 in the next month, that is in the June. Okay, right. So this is the question asked in SSC JEE EE 2023, right? So all of you just read the question and try to guess among the 4 choices which one is correct. So in SSC JEE paper, most of the questions you will be getting theoretical, and some questions will be based on the formula based or even calculation based, but that calculation will be very simpler. Okay, because in the SSC JEE exam you have to attempt more number of questions in less time, right? Yeah, just observe here. In an electrical network, if the quantity of a source is controlled by another voltage or current present in the circuit, such a source is called as. Okay, so you are having a source, but that particular source is controlled by or dependent by other voltage or current. Okay, whenever the word controlled or depends, okay, that word is there, obviously it is the dependent source. Whenever, if they specify that it is producing, suppose if it is a voltage source, it will produce constant output voltage. If it is a current source, it is producing constant current, irrespective of depending on any other parameter like independently. Then in that case, answer will be independent source. Okay, whatever independent sources we are having, we can classify into ideal case and practical case. That is the reason you can observe here, you are having one option ideal, another option like non-ideal. Non-ideal, or we can say it is a practical, both are same. Okay, so all these cases are the sub part of, like option C, option D are the part of option B. Okay, but whatever the sources we are having, broadly we can classify as independent and then dependent. Okay, in this question, according to the context, the answer will be dependent source. Okay, right. Now the next question, all of you give a try. Here in this question, you are having the source symbol. Now you have to identify this particular source belongs to which category. So whatever just now we have mentioned in the previous question, so based on that context, they have given one of the representation of the source. Now among these 4 categories, okay, whatever the dependent sources you are having, that we can classify into 4 categories like this. Now among these 4, this particular source belongs to which category? That is the question. See, how to identify whether the given source is dependent or independent. The first and foremost, whenever the source represented with the circle symbol, then it will indicates independent source. Whenever the source is represented with the diamond symbol or rhombus shape, okay, then that indicates what? Dependent source. that indicates dependent source. Okay, now first and foremost you can observe here you are having what? Direction of current, or you can say arrow symbol is there. Whenever arrow symbol is there, that indicates direction of current flow. So with respect to that, you can identify that it is a current source. If you are having voltage polarities plus minus, then you can consider voltage source. Okay, so the first and foremost important observation, whether you are having circle symbol or diamond symbol. Okay, if you are having circle symbol, it is an independent source. If you are having diamond symbol, okay, then it is a dependent source. Now since you are having direction or arrow symbol, based on that we are saying it is a current source. That means other two options we can eliminate. Now tell me whether it is voltage controlled current source or current controlled current source. This is the most important. Okay, so just observe here this current source value is ID, that is equal to G into Vc. Here G is what? Constant. Here G is constant. Okay, here Vc is what? The voltage across some branch in the circuit. Okay, voltage across some element. Okay, so that means here you are getting output current, it is a function of voltage. So that means it is a voltage controlled current source. Option B is correct. Voltage controlled current source. Okay, similarly, suppose if you are having here the current term, okay, quantity current is, if it is there, then it is like current controlled current source. Just like example, IC equal to beta into IB. If you are having like that, then that particular source is an example of current controlled current source. In this way, don't get any confusion whether it is voltage source or current source. Ultimately based on the polarities. If you are having polarities, it indicates voltage source. If you are having the arrow symbol, it indicates current source. Now after that, here whatever the output you are getting, whether it is a function of voltage or function of current. If it is a function of voltage, voltage controlled. If it is a function of current, current controlled. Okay, here you are having the terms like controlled. Okay, similarly you can have dependent also. Like suppose voltage dependent current source. In place of controlled, you can consider dependent also. Okay, right. So that is the reason earlier we have mentioned here like dependent source. Dependent sources we are calling other name as control sources. Dependent source or control source. Okay, right. Next question. This is a very interesting question. So all of you give a try. So in this question you are having the relation between voltage and current. They have given like this: V of t equal to I square of t. Now the relation between voltage and current. Okay, you are having 4 choices. Now you have to identify among these 4 choices which one is correct. This is very interesting. See, whenever you are having power term like other than 1, like 2 or 3 like that, in this question you are having I square of t. Power you are having 2, right? So whenever you are having power 1, that means it is a linear. Like suppose V of t equal to k times I of t. Okay, so it is a linear function. But whenever you are having I square, I cube, I power 4, etc. like that, other than power 1, if you are having, then we can say that is straight away non-linear. So that means we can eliminate 2 choices, B and D. B and D we can eliminate. Okay, up to here everyone will do correctly. Now after this, here if you observe among A and C, okay, in C you are having like time variant, in option A you are having time invariant. Which one we have to choose? Some students, because here you are having it is a function of time, based on that few students may consider option C. But actually for solving this question, you should have the minimum knowledge of signals and system. Okay, if you are having that minimum knowledge of signals and system, especially regarding the classification of systems when you have studied, okay, based on that one, okay, with respect to time invariant, you might have studied linear, non-linear, time variant, time invariant in the signals and system subject. So whoever having the minimum knowledge regarding the time variant or time invariant, definitely those students can answer this question correctly, right? So here now we have to decide whether it is time invariant or time variant. Okay. Yeah. So here in order to decide whether any particular system, whatever the relation they have given with respect to input and output, whether it is time invariant or time variant. Okay, how to decide? It is very simple. When you have observed this particular equation, I of t is what? When you have observed this equation, when you have observed this equation, here I of t is the current, I of t is the current, right, that you are passing through a particular system. Okay, then you are getting output as what? Then you are getting output as V of t equal to I square of t. V of t equal to I square of t. You are having the input, you have given that input to a some system or network, right? Then with the help of that network or system, you are getting like this. Okay, now whatever the output you got, now you pass this output through a delay liner. Now you pass this output through a delay liner, which is having the delay of t naught. That means in place of t, you are considering t minus t naught. In place of t, you are considering t minus t naught. Now on left hand side, right hand side, in place of t, you can substitute t minus t naught. From there, what you are getting? I square of t minus t naught. I square of t minus t naught. Right, like this you are getting. Now this is case 1. This is case 1. Now similarly, let us consider one more case, case 2. Okay, just observe in the first case what I have taken. I have considered the input, I have given as the input to that network. Then after that I have found the response. Okay, and in that response, whatever I am getting, I am just doing the delayed version. Okay, in case 2, what I am doing here, whatever the input initially we are having, that input I am passing initially through a delay liner. I am passing through a delay liner which is having a delay of t naught. Now in this case, what you will get? I of t minus t naught. I of t minus t naught you are getting. Now whatever this delayed version of input you are having, now I am giving as input for your system. Now I am giving as input for your system. So in this case, say for example, this one I am labeling as V1 in earlier case. Now in this case I am labeling as V2. Okay, so V2 of t or V2. Here in place of, see here you are having I square of t, you can write it as I of t whole square, right? So where I of t is nothing but this entire function, I of t minus t naught whole square. Now this one we can write as I square of t minus t naught. Now whether first equation, second equation both are same or not. Here you got first equation and here you got second equation. If 1 and 2 are same, then that particular system or network is what? Time invariant. Okay, that is a very important. So in this case, the answer will be option A. Option A, time invariant. Suppose in this case, if these two are not same, then in that case time variant. Okay, I hope all of you are getting the clarity. Once again I am repeating, this is a very important concept. Whoever, actually this concept you might have studied in the signal system. Okay, so I am repeating once again, you are having the input, you are applying that input to a network or system, based on that whatever you are getting. Okay, now that output you are passing through a delay liner. Okay, right, you are getting one case. Now another case, what I have done, initially the given input itself I have passed it through the delay liner. Now whatever this input, delayed input I am getting, now I will substitute in place of that particular input expression, right? So from there whatever I am getting, if both equations are same, then that particular network or system we will call it as time invariant. Otherwise we will set as time variant. Okay, that is the most important. Now with this understanding, so all of you give a try for this question. It is very easy question, no need to use pen and paper. Directly you can choose the correct answer. I hope all of you will get the correct answer for this question. Yes, here we are asking the SI unit, of current. So for current units are by default ampere, right? So that means option D is correct. Option D is correct. Okay. But generally, just you can recall, suppose if ampere is not given, okay, if ampere is, since it is given, we have chosen. But suppose if ampere is not given, then what could be the other way to represent the SI unit for current? Okay, so for that I am giving the brief here. Okay, so here we can write Q equal to I into T. Okay, Q equal to I into T, current into time. So from here, just rearrange current equal to charge divided by time. So charge units are coulombs, and time units are second. So that means here actually in option C they have mentioned second per coulomb, but actually it should be coulomb per second. If they have given coulomb per second, then it will be correct. Okay, so here you are getting charge units are coulomb, time units are seconds. So that means coulomb per second it should be. Okay, since they have given ampere, directly you can choose. Whenever they are not giving ampere, then that time they can represent like this, coulomb per second. Okay, ampere or coulomb per second. Ampere or coulomb per second, right? Yeah, next question, all of you give it try. So in this question, you are having time instants 0 second to time instant 5 seconds. From 0 second to 5 second, okay, you are having one particular element. In that element, this much charge was entered. Okay, in that duration, 0 second to 5 second, 12 coulomb of charge is entered. Now the question is, because of that charge, how much current is flowing in that particular element? How much current is flowing in that particular element? So here, see, the basic formula is what regarding current? I equal to dq by dt. Okay, here you can observe in the time interval of 5 seconds, 12 coulomb of charge is entered. So that means 12 divided by 5, that's all. Okay, so here 5 2s are 10, then 5 4s are 20. So that means 2.4 ampere. So option A is correct one. So I hope all of you know this basic formula, I equal to dq by dt. From this formula only I have just rearranged. Okay, after doing the integration on both sides, from there you will be getting Q equal to IT like this. Okay, right. I equal to dq by dt. So here 12 coulomb of charge was there. Okay, in the duration of 5 seconds. So 12 divided by 5, that is nothing but 2.4 ampere. Okay, in this way, whatever the questions you are getting from network theory subject, okay, here these questions, if you observe, these are the formula based questions, but for calculation wise it will take very less time. Okay, here for understanding purpose I am writing the steps, but whatever the calculation required you can do in the mind level, so that in SSC JEE exam time you can attempt more number of questions in less time, because on average for every question you have to attempt, if you want to attempt more number of questions correctly in less time, okay, in the given time, then you have to attempt each and every question less than like half minute. Okay, if you are taking more than half minute for any question in the paper 1, that means you are unable to solve more number of questions, right? So don't spare more than, like suppose after reading the question, if you are able to solve, immediately solve it. Okay, in that way you try to solve, but if whichever question you feel after reading the question, sir, it may take more time or it is a difficult question for me, then you can keep hold of that questions. Okay, you can try later in the second round. In that way, if you are smartly deciding, then because of that you can attempt more number of questions in the given time. Otherwise, the exam time you may feel that, sir, questions are very easy, but somehow other we couldn't attempt the questions. Okay, more number of questions. Okay, if you want to avoid such kind of regret, so play the strategy. The strategy is very important. After reading the question, whichever question you can solve, okay, if you feel that you can solve, you solve it in less time. Okay, whichever questions you feel that it may take time, you can hold those questions for the later round. Okay, right. Now this is also a very interesting question. All of you give it a try. All of you read the question once and then try to find out what they're asking. Yeah, here in this question you're having the charge expression they have given. Okay, up to t less than 0 you're having 0 coulomb. In this interval 0 to 2 you're having 2t. For t greater than 2 you're having the charge expression like this. Okay, in this question you have to find out the current at t equal to 5 seconds. Okay, so here first and foremost important thing, okay, here you are having time instant. So based on the time instant you can observe here now you have to consider in this interval t greater than 2 interval we have to consider, because t equal to 5 seconds exists t greater than 2 interval, right? So this is the charge expression, but now they are asking what? Current. So just now we have discussed the formula I equal to dq by dt. So this formula we will be using. So I equal to dq by dt. So here d by dt of, so this charge expression you can consider. This charge expression we are considering 3 plus e power minus 2 into t minus 2. Okay, so derivative of constant is what? 0. Derivative of constant is 0. Then e power minus x derivative, e power minus x only. After that, whatever this power you are having, that for that power you have to perform differentiation. So from there you will be getting minus 2 into derivative of 2 is 1, derivative of constant is 0. Okay, now you can substitute t equal to 5. Now you can substitute t equal to 5 here. Then from there what you are getting? Negative term you are getting, right? Minus 2 into e power. Here you have to substitute 5. 5 minus 2 is 3. 3 into 2 is 6. So you are getting e power minus 6. E power minus 6 units are ampere. Units are ampere. Minus 2 into e power minus 6 you are having, that is option C. Option C is the correct one. Okay. See, if they have mentioned for t less than 0, then option A will be correct, because here you are having 0, derivative of 0, anyway you will be getting 0. If they have given in this interval any time instant, okay, then derivative of 2t, derivative will be t. Derivative of t will be 1, so you are getting 2. So that means option B will be correct if they ask any time instant in this particular interval. Okay. Option D, instead of current if they are asking charge in any time instant in this particular interval, then when you are substituting here, okay, say for example here t equal to 5 they have asked, if you are substituting, then from there you are getting like this. Okay, instead of current if they are asking charge, then option D will be correct. In this way, for practice you can just consider, because you are having various instances, accordingly you can figure out which option can be correct in which case, etc. If you are doing like that, then you are getting good practice regarding the concept. Okay, right. Yeah, next question, all of you give it a try. Yeah, this is the direct question, right? You can observe here, you are having 5 ampere current that flows through a circuit for 5 minutes. Okay, now they are asking the total charge. Okay, so earlier formula you are having I equal to dq by dt, and from there you can observe earlier question also. After you are performing integration on both sides, from there you are getting charge equal to I into t. Okay, this formula I am using now. Charge equal to I into t. So here current is 5 ampere, then time is what? 5 minutes. 5 minutes. Okay. So some people will choose directly 5 minutes. Then 5 into 5 is what? 25. That is also there in one of the option. But here the most important is what? Whatever the time you are having, you have to consider in the order of seconds. That is very important. Here they have given minutes. That minutes you have to represent as 60 seconds. 60 seconds. If you are not carefully, okay, if you haven't taken care about that like if you have considered instead of minutes by default like second, then because of that you are having one of the option, that is D, but that is D option is not correct for this question, because here they have mentioned minutes, that minutes you have to convert into seconds. Now 5 5s are 25, 25 into 6 150, and then into 10, that means you are getting 1500 coulombs. Okay, so option B is the correct one. In this way you have to take care about the units, it is very important. Okay, right. Yeah, next question, I hope all of you can answer. Just read the question and try to choose among the 4 choices which one is correct. All of you give it a try. Yes, you can observe here you are having the current expression I of t and the voltage expression V of t of a circuit element. Now the question is regarding the power P of t. So in general power formula is nothing but the product of voltage and current. Okay, voltage and current product. So like that you are having in 3 choices. In one choice you are having plus, that option you can eliminate. Okay, now after that they are asking energy. Energy is nothing but integral of power. Okay, so that means here option A is correct one. Option A is correct one. Energy is nothing but integral P dt, integral power dt. Okay, right. So now this is a question based on the earlier formula regarding power. Okay, so in this question you are having the current expression, you are having the voltage expression. Okay, now they are asking power. They are asking the power. So just now we have told power is nothing but the product of voltage and current. Power equal to voltage into current. Voltage into current, right? So here voltage expression is 10 into e power minus 5t, and then current expression is what? 5 into e power minus 5t. 5 into e power minus 5t. Now here 10 into 5, that is 50. 10 into 5, 50. So here regarding 50 you are having 3 choices, but in option B you are having 10. So as of now we can eliminate one option. Okay, now after that you are having e power minus 5t into e power minus 5t. So that one you can write e power minus 5t whole square. E power minus 5t whole square, just like x into x is what? X square, like that you can write. Now after this, here you are having a power m whole power n, that means a power mn, a power mn. So from here you are getting 50 into e power minus 2 into 5, that means 10 into t. Otherwise you can write like a power m into a power n, you can write it as a power m plus n. In that case e power minus 5t minus 5t, that means e power minus 10t, like that also you can consider, no problem. Okay, so here you are getting option D is the correct one. But here sometimes few people will do silly mistake. Here instead of writing like this, okay, 5 e power minus 5t whole square is there, right? So some people will think like this, 5 square means 25. So like that you are having in option C. That option few people may select, but that is not correct, because you are having the formula as what? A power m whole power n is a power mn. That means whatever the powers you are having, you have to multiply, right? Okay. Next question, all of you give it a try. So here you are having 64 kilo ohm resistor. You are having 64 kilo ohm resistor has a specified maximum power dissipation. They have mentioned the power dissipation 1000 watts. 1000 watts. Okay, and they are asking the maximum current that may be passed through that particular resistor. Okay, so regarding resistor, okay, whatever the power formula earlier we have mentioned, like power equal to voltage into current, V into I. Okay, but for a resistor you are having other derived formulas, right? So suppose if you are considering the basic formula with respect to Ohm's law, V equal to I into R, V equal to I into R. So in place of V, if you are substituting IR, then what you are getting? IR into I So from here you are getting I square R. Similarly, in place of I, if you are writing V by R, then accordingly you are getting V square by R. Okay, like that, based on the given information, any formula you can use. Okay, right. So now consider power given as 1000, which is equal to, here we have to calculate the current. Okay, so I square into resistor value given 64 kilo. 64 kilo we can write as 1000. So 1000 will get cancelled, right? So from here what you are getting, I square equal to 1 by 64. I brought 64 to the left hand side, it will come into the denominator, right? So from here you can write I equal to 1 by 8. Units are ampere. I equal to 1 by 8 ampere. So option D is the correct one. Option D is the correct one, right? Yeah, next question, all of you give it a try. In this question, you have to find out the energy, how much energy was consumed. See, earlier question with respect to power, now the question based on energy. Okay, so how much, find the electrical energy consumed in 10 ohm resistance when 100 milliampere current flows for 2 minutes. Okay, so just observe the question. Okay, what you are supposed to calculate and what the given data is there. Based on that, you can use the whatever the basic formulas you are having with respect to resistor, accordingly you can use. Okay, so in this question, if you observe, you are having current, you are having resistor. Okay, just now we have calculated the power formula, this one, power equal to I square R. Right? Now, but in this question, the question is based on energy. Okay, so energy is nothing but integral P dt. Okay, and in place of P, you can substitute I square R. Right? Now here what you are having? Energy we have to calculate integral I square R dt. Okay, so here I square, I is constant, R is constant, integral dt is nothing but t. So from here you are getting I square R into t. Okay, now we have to calculate energy. You are having the current, you are having the resistor, you are having the time, all the parameters you can substitute, that's all. So here current value given 100 into 10 power minus 3 because it is milliampere whole square. Then resistor value is 10 and time given 2 minutes. Now here also very important, because it is given in the order of minute, now we have to convert into seconds, right? So 1 minute is nothing but 60 seconds. Okay, so here 100 into 10 power minus 3, that means 10 power minus 1 whole square. So from here you are getting 1 by 100. Okay, 100 into 10 power minus 3 means 10 power minus 1. I am writing it as 1 by 10. 1 by 10 whole square is 1 by 100. Okay, then here you are having 10 into 10, that is 100, and then 2 into 6, that is 12. So here 100 will get cancelled, you are getting 12 joules. Okay, so option D is the correct one. So whenever in the question they have represented regarding the time in the order of minutes or hours, convert into seconds. Okay, because whatever the standard units you are having, like joules or watts, etc., or even earlier coulombs, right? All these standard units, whatever you are having, that you are getting when you are considering the time units are seconds. That is very, very important. Okay. Next question, all of you give it a try. Yeah, here you can observe they have framed the question based on the real-time application. You are having the heater. So in the heater you are having the resistance 300 ohm. Okay, that heater they have connected to the main supply for 10 minutes. Okay, for 10 minutes they have connected. If the heat produced in the heater during this time is 18 joule. In this question they have given the energy. Okay, now you have to calculate the current. You have to calculate the current. Okay. So just now we have used this formula regarding energy. The final derived formula is this one, I square R into T. Okay, this formula I am considering energy equal to I square into R into T. I square R into T. See, it is very simple. Regarding power formula, you know, I square R, just multiply with time. Okay, that's all. Okay, right. So in this question, 18 joules given, and current we have to calculate. Okay, current we have to calculate. Then resistance value given as 300 ohm, 300. Then time given as 10 minutes, 10 minutes. 10 into minutes means 60 seconds. 1 minute equal to 60 seconds. Okay. Now you can observe here 3 into 6, that is nothing but 18. 18 will get cancelled. Okay. And then here you are having 100, here also 100. Together 10 power 4. So from here I am writing like this, I square equal to 1 by 10 power 4. 1 by 10 power 4. Okay. So just apply square root on both sides. I equal to 1 by 100. That is equal to 0.01 ampere. 0.01 ampere. Right. So here you are having option B. See, in some questions they will give fraction of two numbers. If they have given like that, then in that case you can consider 1 by 100. But in this question they have converted into normal values. So based, whenever you are solving any question, have a look at the choices, accordingly you can convert. Okay, in the part of the solution, what is the answer you are getting, based on the given choices you can convert into the required format. Okay, right. Yeah, next question. I hope all of you can answer this question easily. Okay, this is a straightforward question, dead easy question. Here they are asking with respect to joule. Joule is the unit for what? Energy. Just now we have discussed. Okay, in general we are representing energy in the order of joules. Okay, the unit for energy is joules. But in this question, regarding the joule, what is the one more form of representation? That is the question. What is the one more form of representation? See, just now I have told here I square into R is nothing but what? Power. Okay, and then we are multiplying with what? Time. Okay, so power units are what? Power units are watt. Okay, and time units are second. So that means option A is correct. That's all. Yes or no? Energy equal to the product of power into time. So power units are watt, time units are second. So watt second. Okay. Next question. This is a question based on resistors, right? So here I hope all of you can answer this question correctly. All of you give it a try. All of you give it a try. See, here you are having 150 ohm resistor, 200 ohm resistor, 600 ohm resistor. 3 resistors they have given, and all the 3 resistors are connected in parallel. All the 3 resistors are connected in parallel. Now they are asking the effective resistance or equivalent resistance, all are same. Okay. So you can do one way of solving this question is 1 by R equivalent as 1 by R1 plus 1 by R2 plus 1 by R3. Of course, you will get the same answer, but it may take more time. Okay. If you want to answer this question in less time in the exam, you can follow this strategy. First, you can consider with respect to 200 ohm and 600 ohm. Okay. If you are considering 200, 600, both are parallel, right? So 200 into 600 divided by R1, R2 divided by R1 plus R2. So direct step I am writing 800. Okay, here 2 zeros will get cancelled. Then 200 times, then here 4 times. Okay. Then 2 2s are 4, 2 50s are 100, then 2 3s are 6. So that means you are getting 150 ohm. You are getting 150 ohm. After doing the simplification of equivalent resistance by considering these two, you are getting 150 ohm. Now just observe, the moment you are getting 150 ohm as one resistor, now that resistor and this resistor both are connected in parallel. Both are connected in parallel. So 150 parallel to 150. So that means when both the resistors are having the same value, then the equivalent resistance will be R by 2. That means 150 divided by 2, there is nothing but 75 ohm. 75 ohm. In this way, if you do calculation, instead of doing like 1 by R equivalent as 1 by R1 plus 1 by R2 plus 1 by R3, see that calculation you can do whenever they are giving resistor values like 1 by some other numbers. If they are doing like that, then you can easily do the calculation there easily. Okay, but when they are giving normal values like this, better you can follow like this. With the help of this one, you can easily solve the question in less time. So the answer for this question is option A. Option A, 75 ohm. Yeah, this is a very interesting question. All of you give a try. This is a very interesting question regarding the equivalent resistance. Earlier question they have straightforwardly mentioned the given resistors, how they are connected. But in this circuit diagram, you have to carefully observe. Okay, if you are carefully observing, then only you can figure out which resistors are like in which configuration they have connected. It is very, very important. See, question wise or circuit diagram wise, it is not at all complex, but only thing you should have the patience and you have to observe among the given resistors, which resistors connected in which configuration. That is a very, very important. See, in this question, if you observe, this point, and this point, all are same or not? Yes or no? These 2 points are same, and this point, because both are connected with one wire, right? Okay. So that means if you carefully observe, here you are having node C. Okay. Between C and A, you are having 10 ohm resistor, and now between same C and A, you are having one more resistor 15 ohm. Yes or no? See, you have to visualize like this. Between these 2 points, you are having one resistor 10 ohm, and between the same points, you are having one more resistor 15 ohm. That means 10 ohm and 15 ohm both are connected in parallel. 10 ohm, 15 ohm both are connected in parallel. So R1, R2 by R1 plus R2, right? So 10 into 50, 15, that is 150 divided by 25. That means you are getting 6 ohm. Okay, by considering these two are parallel configuration, you are getting the equivalent resistance as 6 ohm. Okay, after that, if you carefully observe, between the point A and between point C, you are getting equivalent resistance as 6 ohm, and between C and here all these points are same. Right? So between C and E or B, all points are same. Okay, here you are having 8 ohm resistor. Okay. Next, now just observe, here you are having what? One resistance 14 ohm that exists between E point and then A point. You are having 14 ohm resistor. See, now you can observe these two, how they are connected. 6 ohm, 8 ohm series. That means we can add 6 plus 8, that is 14 ohm. Now you are getting one resistor between A and E, that is 14 ohm, and one more resistance 14 ohm. Both are having same value. Both are connected in parallel. So that means RAB equal to 14 parallel to 14. So that means 14 by 2, that is 7 ohm. That's all. Option A is correct. In this way, if you are able to visualize the given circuit, we can easily solve in less time. But if you are unable to visualize, then it may take more time. Okay, here first and foremost important point, whenever you are having multiple connections like this, just observe which points are same. After that, try to represent in the equivalent simplified form. After that, you can proceed accordingly. Okay, the final answer for this question is 7 ohm. Right. So up to here, we have discussed the questions with respect to sources and then with respect to energy, power, current, charge, and then resistors, everything. Now we are solving the questions based on inductors. Okay. So here in this question, you are having the inductance value 20 Henry and the current in the circuit changes at the rate of 50 milliampere per second. Now they are asking the self-induced EMF. Self-induced EMF or voltage, both are same. So the voltage across inductor is nothing but L into d by dt. So here in this question, L value given as 20 Henry and di by dt directly they have given. You can observe they have mentioned circuit changes at the rate. Whenever the word rate is there, that means here denominator term is t or units are seconds, like that. Or you can observe, numerator you are having in the order of ampere, denominator you are having seconds, so that means you are getting dI by dt. Okay, so 50 milli you can write as 10 power minus 3, 10 power minus 3. So here 2 into 5, that is 10, then here 2 zeros are there, then 10 power minus 3 we can write as 1 by 1000. So 1000 will get cancelled, you are getting 1 volt, 1 volt. Okay, voltage across inductor or self-induced EMF, both are same, that is 1 volt. Yeah, next question also dead easy question, dead easy question. So here in this question you have to calculate the inductance value. Okay, in this question they have given the voltage, okay, 150 volt they have given, and the current rate of current they have given, okay, 3 ampere per second. So the same formula you can use, voltage equal to, here in this question voltage equal to 150. See the same formula I am using, voltage equal to L into dI by dt, the same formula I am using, right. Voltage is 150. Now L value we have to calculate, dI by dt they have given 3. So here 3 50 times. That means L value is 50 Henry. Inductance value is 50 Henry. Option A is correct. Okay, in this way if you are having the basic formulas command, you can do the calculation without using pen and paper. Okay, that much direct questions, simple questions. Yeah, next question, all of you give a try. I hope all of you can answer, but only thing, whatever the given data is there, you have to understand it carefully. If you are understanding carefully, definitely you can get the correct answer. Here in this question they have mentioned the potential difference across a particular element is, here potential difference, or another word you can say voltage, all the same, okay, is proportional to the rate of change of current, the rate of change of current. See, just now only we have mentioned voltage equal to L into dI by dt. Here L is what? Constant. Okay, if you are removing L, then you can mention proportionality. Voltage across inductor is directly proportional to dI by dt, dI by dt. So that means here we can say inductor, that's all, inductor. Okay, voltage equal to L into dI by dt, there L is the proportionality constant. If you want to remove the proportionality constant, then you can represent the symbol proportional. Okay, right. Next question, all of you give a try. In this question you are having 15 ampere current is flowing through a solenoid which is having an inductance of 4 Henry. Find the magnetic energy stored in the solenoid. Okay, so I hope all of you know the standard formula regarding energy stored by the inductor. Okay, energy stored by the inductor is equal to half Li square, half Li square. Okay, in this question we have to calculate the energy. Okay, you can represent half as it is. Then inductor value given as 4 Henry and current flowing is 15 ampere, right? 15 ampere, here 15 whole square. Here 2 times, then 15 square is nothing but 225. So 2 into 225, okay, so is nothing but 450. 225s are 50, 2 into 200 is 400. Together you are getting 450. Since it is energy, units are joules. So 450 joules you are having, option B. Option B is the correct one. See, all these questions you can observe, once if you know the standard formulas, you can directly substitute the given data and you can find out the unknown. There is no twist at all. Okay, but only thing, if you are able to recall the formula and if you are able to substitute the given data and you can do the calculation in the mind level wherever possibility, because this calculation also for understanding purpose I have written, but if you are able to do at least some part of the calculation in the mind level, from there you can choose the correct option in less time. Right. Yeah, next question, similar question. Okay, but in this question they have given energy. Okay, in the earlier question we have to calculate the energy, but in this question energy already given. Energy is 160 joules and inductor value also given. Now we have to calculate current. see, when you are having the formula like this, okay, in this formula you are having 3 parameters or 3 quantities, among which earlier they have given 2 quantities, L and I, they asked the energy. But in this question, energy and inductor they have given, they are asking current. Okay, same formula you can use. Energy equal to 160, that is equal to half Li square. L value is 5, current we have to calculate, half Li square. Okay, so here 5 3 is 15, then 5 2s are 10. Okay, do the cross multiplication. From here you are getting I square equal to 64. From here you are getting I equal to 8 ampere. I equal to 8 ampere. So option C is the correct one. Option C is the correct one. Okay. Next question, similar question, but it is a very interesting question. Similar question, but it is a very interesting. All of you give a try. All of you give a try. See, just like the earlier question, they have given the energy. They have given the energy. So first of all, okay, energy I am representing 2 kilo. Kilo means 1000. Okay, watt, that is a normal unit regarding power. And then here hour is there. Hour. Okay, hour is nothing but 60 minutes. Hour is nothing but 60 minutes. And 1 minute is nothing but 60 seconds. This is the most interesting thing and important thing in this question. That is a only twist. Okay, so energy, generally few students may write up to this point, but here since it is hour is represented, hour is nothing but 60 minutes and 1 minute is nothing but 60 seconds. This much you have to write. So energy stored in the inductor is equal to half L value. Here also we have to calculate inductance. Okay, half L into I square. Okay, I value given, that is 100 whole square. Okay, right. So here you can observe you are having 1000 and then here into 10 power 4. So here 10 power 4, both will get cancelled. Okay, then do the cross multiplication. So L equal to 2 2s are 4 into 6 6 are 36 into 10 or 360 you can write. Okay, so here 0 I am writing, 4 into 36 you will be getting 144. Okay, so that means option C is the correct one. Units are Henry. 1440 Henry. Okay, here in these questions if you observe, the most important thing you have to take care about the units. Once if you are taking care about the units, definitely whenever you are solving any question, whatever the answer you are choosing, definitely it will be correct. Okay, right. Yeah, this is the question based on the inductor's equivalent circuit. Okay, in this question you have to find out the equivalent inductance with respect to the terminals A and B. L equivalent you have to calculate. All of you give a try. See here how these two inductors are connected, series. See, regarding the resistors and inductors, whatever the formulas you are getting with respect to resistors, similar formulas will applicable with respect to inductor. Okay, there you are considering R, here you are considering L, that's all. Okay, here 3 Henry, 1 Henry, both are connected in series. In series we can add 3 plus 1 is 4 Henry. Now this 4 Henry inductor and 12 Henry inductor, both are connected in parallel. Okay, so 4 Henry and 12 Henry both are connected in parallel. So L1 L2 divided by L1 plus L2. Okay, so here 4 times and 4 3 times. That means you are getting 3 Henry. So this entire combination to the right hand side you are getting 3 Henry. You are getting 3 Henry. That means this entire configuration you have replaced with one inductor which is having the value 3 Henry. Now with respect to A and B terminals, when you are looking this circuit, you are having 3 inductors. All the 3 inductors are connected in series. That's all, right? So in series we can add the inductances. So L equivalent or equivalent across the terminals AB. L equivalent across the terminals AB is nothing but 5 Henry, then 3 Henry, and then 15 Henry. So 15 plus 5, 20 plus 3, that is 23 Henry. 23 Henry, option D is the correct one. Option D is the correct one. Right. So all of you read the question once. And here we are having the configuration regarding the inductors. Okay. So here you are having two coils which are having the self inductances 30 Henry and 40 Henry. You can consider like L1, L2. Okay. And these two are connected in series but opposing connection. Opposing connection. Okay. Find the total inductance of the series connection if the mutual inductance between the coils is 0.5 Henry. Okay. See, earlier question, whatever we have discussed, in that question there is no coupling. Okay. When there is no coupling, what are the formulas earlier we have discussed? Same formula. Okay. But whenever they have mentioned coupling is there, accordingly you have to consider the respective formulas. Okay. In this question you are having series. Okay. So L equivalent is L1 plus L2. Suppose if there is no coupling. If there is no coupling. But in this question they have mentioned series opposing, that means the formula is minus 2m. If you are having series aiding, then in that case plus 2m, like that. Okay, right. So L equivalent we have to calculate. L1 given as 30 Henry, L2 given as 40 Henry minus 2 into mutual inductance is 0.5. 0.5 I am writing it as 1 by 2 just to do the calculation simpler, or otherwise you can substitute 0.5, no problem at all. Here 2 will get cancelled. Okay, so that means you are getting 1. So 30 plus 40 is 70, 70 minus 1, that is 69. So 69 Henry. So option A is the correct one. 30 plus 40 is 70, 70 minus 1, 69, 69 Henry. Now all of you tell me, after looking at this diagram, how these two inductors are connected. Any guess? Yes, obviously these two inductors are connected in series. Very good. Now with respect to coupling, whether it is opposing or aiding. In the earlier question they have directly mentioned whether it is opposing or aiding, but in this question they haven't mentioned, but from the diagram you have to identify. Yes, very good. See, you can observe here, say for example when you are considering the inductors like this, let us assume that current is entering like this. Okay. So here current enters at the dot terminal, but here current leaves from the dot terminal, right? So suppose if current enters here, here also current enters at the dot terminal, then it is the case of aiding. But in one inductor current enters at the dot terminal, in another inductor current leaves from the dot terminal, then that is the opposing. That means this particular configuration, instead of directly mentioning that is a series opposing, but they have given the circuit representation. Okay, so this is the circuit regarding series opposing. Series opposing. Okay, I hope all of you got the clarity how to identify whether it is opposing or aiding. Okay. Now once again they are asking the equivalent inductance only. So equivalent inductance formula is same. L equivalent is L1 plus L2 minus 2m. Okay. L1 is 2 Henry plus L2 is 6 Henry minus 2 into mutual inductance is 1 Henry. Okay. So plus 2 minus 2 will get cancelled. So you are getting 6 Henry. See here for understanding purpose I have written, but actually the moment you have observed that 2 Henry, 6 Henry and mutual inductance is 1, by using the standard formula you are getting minus 2m. Minus 2 plus 2 will get cancelled, you are getting 6 Henry. That's all. Option C is the correct one. It won't require much time. But only if you want to get good command, if you want to get the speed, you have to practice sufficient number of questions. Once if you are having confidence on the basics and once if you know the process, then you can solve the questions in less time. Okay, right. Yeah, next question. All of you give it a try. In this question you have to find out the mutual inductance. Mutual inductance. And here the most important thing you can observe here. Here they have mentioned total inductance of two coils. Okay. So regarding these two coils they have mentioned equally likely. That means both the coils are having the self inductance is same. Okay. Are these two coupled coils in the series aiding. Okay. That time they have given the equivalent inductance as 4 Henry. And similarly in the series opposing case, that time they have mentioned 2 Henry. 2 Henry. Okay. Now they are asking the mutual inductance. Okay. See, first I am writing L equivalent formula for series aiding case. For series aiding, L1 plus L2 plus 2m. Okay, this is the case for series aiding. Okay, but in the question they have mentioned both are having equal likelihood. That means both the self-inductance are same. So L1, L2 you can consider same. L plus 2m. So from here you are getting 2 into L plus m. 2 into L plus m. Okay, but according to this question, this entire value is nothing but 4 Henry. 4 Henry, right? So here 2 times. So from here you are getting one equation that L plus m equal to 2. You can label this one as equation number 1. Equation number 1. Now, regarding series opposing, L equivalent, we already know the formula, right? L1 plus L2 minus 2m. L1 plus L2 minus 2m. Because in this question L1, L2 both are same. So direct step I am writing 2 into L minus m. That is equal to 2 Henry. Okay. So here in this case 2 will get cancelled. From here you are getting L minus m equal to 1. So you are having in equation 1 L plus m, in equation 2 L minus m. In this question they are asking mutual inductance m. So for that what you can do? You can subtract 2 from 1. Yes or no? If you are subtracting 2 from 1, what will happen? L will get cancelled. Plus m minus of minus m. That means plus m. So together you are getting 2m. Direct step I am writing. Then 2 minus 1 is 1. So from here you are getting m equal to 1 by 2, that is 0.5 Henry. M equal to 1 by 2, that is 0.5 Henry. Option B is the correct one. Option B is the correct one. Yeah, this is the last question regarding this session. All of you give it a try. This is the question based on coefficient of coupling value. They are asking the value of coefficient of coupling. See, in this question you are having self-inductances values L1, L2 you are having, okay, and they are magnetically coupled. The mutual inductance they have given, 3 Henry. Now they are asking the coefficient of coupling value. Okay, I hope all of you know this formula. Coefficient of coupling value K is nothing but m divided by root L1, L2, where m is the mutual inductance, L1, L2 are the self-inductance values. Okay, so in this question m value they have given 3 Henry, okay, divided by root L1 is 18 and L2 is 2. So 18 2s are 36, okay, root 36 is nothing but 6. So 3 by 6 is nothing but 1 by 2, which is nothing but 0.5. So in general, coefficient of coupling value lies between 0 and 1. Minimum value is 0, maximum value is 1. So here in this question, option C is correct. Option C is correct. Okay, in this question, all the choices you are having, the values lies between 0 and 1. But suppose regarding coefficient of coupling, whenever they are asking, suppose if any choices you are having greater than 1 or if you are having negative value, okay, straight away you can eliminate those choices. Okay, so this is the standard formula regarding coefficient of coupling. K equal to m divided by root L1 L2. M divided by root L1 L2. Okay, so in this particular session we have covered total 26 questions which are based on SSC JEE recent year, previous year questions. Okay, and in this particular session I have covered the questions based on these topics, right? So initially we have seen 2 questions based on active elements, sources, and other questions we have discussed based on current, charge, in terms of power and energy, and then we have discussed the questions based on resistor and inductor, right? So with respect to energy, power, and then equivalent circuits, every important model we have covered. Okay, whoever attending this session, definitely they are getting the good command over these concepts. Okay, so all of you kindly share this video link with all of your friends so that whoever writing SSC JEE exam in the next month, definitely they can get good number of marks from this particular subject. Okay, so this is the first session regarding network theory subject. So similarly in the next session I am going to cover the concepts, the questions based on capacitor and then basic laws of the network theory subject. Okay, so all of you kindly like and share our video links, okay, with all of your friends so that they also will get benefited from this series of lectures what we are doing. Okay, and whatever earlier in this particular session I have mentioned regarding our Telegram channel, whoever not yet joined till now, all of you kindly join, because it is free for everyone. Okay, all of you are getting all these benefits for free of cost, right? So just you have to join, that's all. Just you have to click on this link. That link is provided in the description, right? Just you have to click on this link and then join, that's all. After you are joining, all these updates you are getting for free of cost. Okay, right. And then one more important update, whoever targeting for GATE 25-26, here at our IMS GATE Academy we are having live online program, right? Whoever want to get very good rank in the upcoming years, so you people can contact to any of these two numbers. Our counselors will discuss in detail about our live online program, right? All these benefits you are getting, okay, if you are enrolling for live online program, right? So like here, whoever want to get very good rank in the upcoming years, right, here at our IMS GATE Academy we are providing each and every resource that is required for all the sincere students whoever wish to get very good ranks. Okay, so here we are providing 800 plus hours of live online classes. For every subject we are providing theory book, exercise book. Okay, and then we are providing our unique, one of the unique book at our IMS GATE Academy, that is the GATE question bank. Okay, here we are having 34 plus years of GATE questions along with the detailed solutions. And whoever solving the questions from this GATE question bank, after they are attending the live classes and then practicing the exercise book questions, definitely they are getting the good command. In fact, they are getting the confidence about each and every subject. Okay, once if you are confident, then when you are attempting these, whatever the test series we are providing, okay, you people can attempt those tests with the confidence. Okay, definitely with the help of that, in future, okay, when you are writing the GATE exam in 25-26, definitely you can get very good rank. Okay, so in addition to that, we are providing 12 my plan sessions. Each and every student, they can get the proper guidance and study plan with the corresponding mentor, so that in their GATE preparation, whatever the challenges they are facing, they can discuss with the mentor and they can get the proper solution, right? So in this way, we are giving the complete support for every enrolled student. So all of you kindly share this valuable information, and whoever targeting for 25-26, don't wait. Okay, just you can contact to any of these numbers. Our counselors will discuss in detail about our live online program, and then you can enroll as soon as possible so that you can get very good rank in the upcoming years, right? Okay. And not but not the least, okay, whoever watching, whoever coming to our YouTube channel very first time regarding IMS GATE Academy, so all of you kindly subscribe and then click on the bell icon so that you will be getting instant notifications whenever we are uploading any video, okay, in future. And all of you kindly like and share this video link with all of your friends so that they also will get benefited from this series of sessions that we are doing regarding SSC, JEE, EE with respect to network theory subject, right? So all of you kindly share your valuable experience after watching this particular session, whatever regarding this particular network theory subject, whatever the concept based questions we have discussed in this particular session. So regarding these concepts, okay, what is your confidence level and how much helped these series questions, whatever 26 questions we have discussed in this particular session, how much like benefited, okay, with the help of this particular session. All of you kindly mention your valuable experience in the comment section so that your comments means a lot for us. Okay, so all of you kindly like and share this video link with all of your friends, and stay tuned to our YouTube channel. You will be getting the upcoming sessions as well regarding network theory subject. Okay, so thank you everyone.